Okay, so special quadrilaterals day. Yay. Things you have to understand, okay? A quadrilateral is a polygon, right? And it's got 4 sides. There's nothing more special about it than that. So this is a quadrilateral. It's made up of line segments, it's closed, it's a simple figure. What else is it? Yeah, line segments, simple. Here, I kind of describe it this way. So this one is not made up of line segments, is it? So that's not a polygon. This is not a simple figure. That makes sense? Okay, so see how that's like 2 different figures put together? So it has to be a simple figure. So this is not a polygon. This one is not closed, right? So it's not a polygon. Simple, closed figure made up of line segments. Is that all there is to it? Well, for a parallelogram it does, right? I was just talking about, but yeah, for a polygon. So, and then if it's a quadrilateral, so a fourgon, then we have the 4 sides. If you get a little more to it, so a parallelogram would kind of be the next one here. It's a quadrilateral, and it has 2 pairs of parallel sides. And we know all this stuff about it. We know the opposite sides are congruent. We know the opposite angles are congruent. We know that all the consecutive angles are supplementary, right? And we know, what do we know about the diagonals? Yep, they bisect each other. So there's a whole bunch of stuff going on with the parallelogram. Now, if you get a little more going on here, now we can come down and start talking about the rhombus next, okay? So a rhombus, it's a quadrilateral, right? Okay, and it's a parallelogram. So it has all, we know everything you know about a quadrilateral, yes. Everything you know about a parallelogram, yes. Okay, but then not only are the opposite sides congruent, but in a rhombus all 4 sides are congruent. So that's what makes it special. Okay, and in a rhombus, you know, your opposite angles are going to be congruent. The diagonals are going to bisect each other, all that kind of stuff. But, well, let's look at the diagonals here for a second. First of all, are these diagonals the same length? No, you're going to have a long one and a short one, aren't you? Okay. They are going to bisect each other, just like, because it is a parallelogram. But there's something special that happens in a rhombus that doesn't happen if it's just a parallelogram. Can you see what it is? So yeah, so to make it a rhombus, all 4 sides are the same length, but there's something special about the diagonals of a rhombus. What did you say?
They're perpendicular.
Yeah, that's right. The diagonals are perpendicular in a rhombus. That doesn't happen if it's just a parallelogram. It only happens if it's a rhombus. So let's see. I wonder when we look at a parallelogram how we might tell if it's a rhombus or not. One way would be, well, all 4 sides are congruent, right? The other way would be, there you go, the diagonals are perpendicular. So that would be another shot. Now, rectangle. Oh, P.S. This one is equilateral, right? So it's an equilateral parallelogram. Not just the equilateral quadrilateral, it's an equilateral parallelogram. Okay? I can draw a quadrilateral that is equilateral. Okay, and it might be a parallelogram like that, but it might be, I don't know if I can do it. I was thinking I could do it, but I don't know if I can. I don't know if I can draw a foregone and make it equilateral without it being a rhombus. That's a good question. Okay, rectangle. It's not equilateral. What is it? Come on. Yeah, equiangular. Equiangular. Okay, so it is a parallelogram, right? So all the parallelogram stuff, yes. Okay, all of the quadrilateral stuff, it's a polygon. All that stuff is true. All the parallelogram stuff is true, but there's a special deal about rectangles, other than that it's equiangular. Do you guys know what it is? You should know what it is. Do you know what it is?
Isn't it that their diagonals are bisect each other and they're congruent both ways?
Yes. Yes. So, let me tell you a story. My buddy he's got this house, and he's putting a deck on the back. And he starts putting the boards on the deck. So he's got these boards set in the ground vertically on some posts. But as he goes across, the boards want to keep walking over, and so when you look at this edge right here, the boards they always look like this a little bit. And he just keeps adjusting and adjusting and adjusting, and he just can't get it. And he's been messing with it forever and can't get it. And finally he calls me and asks me if I'll come look at it. And of course I know what's going on right away, but I ask him about it, and he's like, this is 20 feet, this is 20 feet, this is exactly 20 feet, this part's exactly 20 feet. What is going on? Well, it wasn't a square, or it wasn't a rectangle. Okay, we're just talking about rectangles right now. But what did I do? I put a measuring tape on that corner, and I measured to that corner, and I checked the length of it. Okay, then I came over here, put the measuring tape there, went over like that, measured that length. Guess what? They weren't the same length. Okay, now if it was a rectangle, should they be the same length? Absolutely. They've got to be exactly the same length. So we had to kick this over about 3 or 4 inches and bring this one over 3 or 4 inches and just square it up, okay? Get the diagonals just the right length, and then everything went on perfect and we didn't have a problem. When I build a lot of furniture, and let's say I'm building a bookcase or something, and I get 4 boards like that, and I put them in the clamps to clamp it together and glue it all together. Okay, as I start to tighten those clamps up, what do? I measure the diagonals. I measure the diagonal here, I measure the diagonal here, and then if they're not exactly the same, I adjust the clamps differently. I'll put different amount of pressure on this clamp to here, and I'll square the cabinet up and get it perfectly square by checking the diagonals. Okay, make sure everything's right. When you wreck your car, they put it up on a rack and they check to see if you bent the frame. Okay, so on a car you have one wheel hub here and one here and one down here that holds the wheel and one down here. Okay, if they measure across like that and that frame isn't exactly the same on both diagonals, you have a serious problem, don't you? Okay, And that's something that's extremely difficult to fix. Can be, but it's not easy. So that's the deal with a rectangle, and that's how you tell if something is a rectangle. If it's a quadrilateral, let's say you don't know anything about the angles here, okay? You just see a quadrilateral like this, and the diagonals are the same length. Does it have to be a rectangle? Is there any other possibility?
It doesn't have to be.
Doesn't have to be? What else could it be?
It could be like, well, I didn't think of it, but it could just be any other irregular.
I'm just wondering. I mean, if we've got a shape like this, is it possible that the diagonals can be the same length? What do you think?
Because you could just get two lines that are equal in length and just make them so that they intersect like not on the bisectors. And then they would be
Oh, I didn't get that very well. Darn it. Here, that's better. Okay. This is an isosceles trapezoid, if we ignore this one line. You guys hot enough? Turn that down. There we go. Isosceles trapezoid. These two are parallel. These two are the same length. If I measure the diagonals here, okay, they are going to be congruent. They are going to be the same length. Okay? But it's not a rectangle, isn't it? Is it? So, how do I know if it's a rectangle? So, you know, here I have a rectangle, or I have a quadrilateral, and its diagonals are the same length. Okay? Now, if this one's a parallelogram, not only are these going to be the same length, what else are they going to do? Yeah, they're going to bisect each other. And in fact, all four of those little bits there are going to be the same length, aren't they? Because if the total lengths are the same and they bisect each other, then all four pieces will be the same length, won't they? So be a little bit careful when you're looking at it and determining, okay, is this a rectangle or is this not a rectangle? All right, what about a square? So a square is both equilateral and equiangular quadrilateral. And it's a parallelogram. So it's a quadrilateral, it's a parallelogram, it's a rhombus, it's a rectangle. It's regular, right? It's a regular figure. So square has all of the attributes of all of these different shapes. It's four-sided, it's a polygon, the opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other. The diagonals are the same length because it's a rectangle. The diagonals are perpendicular because it's a rhombus. There's a lot going on to make something a square. Perpendicular. All four of these pieces are going to be the same length. Lots of stuff with a square. So a square is a regular parallelogram. Can we say it that way? Agreed? A regular parallelogram. If you look on page 389, please. At the top of page 389, you see a Venn diagram, which just kind of shows what I've shown you here as well, and it shows how things work together. So they begin with the big box, which is a parallelogram, and it could have an even bigger box around it, which would just be quadrilaterals. But there we have parallelograms, rhombuses, or rhombi. I thought plural was rhombi. I don't know. Anyway, rectangles and then squares are a little bit of everything. Let's look down at example 2, partway down the page. Let's classify that thing. Is it a polygon?
Yeah.
Is it a quadrilateral?
Yeah.
Is it a parallelogram?
Yeah.
Yeah? The opposite sides are congruent, aren't they? Okay, it's a parallelogram. And then can you go even further? What is it? Yeah, there you go. It's a rhombus. Okay. Can we go further? Is it a square? No. Is it a rectangle? No. All right. What if what if we put one of these figures in a coordinate plane and ask you what type of figure is it? Is that going to be harder or easier? Should be easier, shouldn't it?
Yeah.
Because you've got some different tools, right? You've got distance formula, you have all this other stuff. I wanted to show you something. When all you're doing is checking to see if two lines are the same length, like two sides of a quadrilateral are in fact the same length. You don't necessarily have to use the distance formula to figure out if they're the same length. If you just look at the slopes, okay, the rise here is 1, 2, 3, 4, 5, 6, 7, 8, and the run is 1, 2, 3, 4. Over here we have a rise of 1, 2, 3, 4, 5, 6, 7, 8, and we have a run of 1, 2, 3, 4. So are these two congruent?
Yeah.
We don't need to know exactly how long they are to know that they're congruent here, right? When we use the Pythagorean theorem, 4 squared plus 8 squared is going to equal 4 squared plus 8 squared, isn't it? Okay. Plus, we can see that they're parallel, aren't they? Do they have the same slope? What is their slopes?
No, 2.
Is it 2 or a half?
It's 2.
2. There you go. So 8 over 4, so 2. So if I were to connect that line like that, would I have a parallelogram? How would you know? What would the proof be? These two sides are parallel, right? And they're the same length, right? So if I have a quadrilateral and two of its sides are the same length and parallel, what do we know? It has to be a parallelogram, doesn't it? Okay. Let's turn over to page 391. Example 4. You're building a frame for a window. The window will be installed in the opening shown in the diagram. So it's 33 by 44 window. The opening must be a rectangle. Give the measurements in the diagram. Given the measurements in the diagram, can you assume that it is a rectangle? So I've done a lot of work for people, and one of them, I went and installed a bunch of doors for them, and they'd taken an attic and modeled it and made a couple of bedrooms out of it and framed it up, and they had the walls all framed up, like this. And they wanted me to come in and put these doors in. And when I measured the doors, it was 82 here, 82 here, 36 here, 36 here. So the opening, perfect. How do you think that door fit in there? Yeah, Logan, exactly. It didn't fit. And I was trying to put a door that was actually a 34-inch door. So we have a 36-inch opening here. So this opening right here is 82 by 36. So I actually had an inch on each side of the door to get it in there, and then you can square it up, square the door up, even if the opening isn't square. I still couldn't get the door in there. I had to go get my hammer and pound these things around and re-nail them and get it squared up before I could put this 34-inch door in there. How come? 36, 82, 36, 82. What was the problem? Yeah, these were not right angles. Not right angles. If I measured the diagonals of that door, are they going to come out to be the same length? No. One of them was like 2 inches longer than the other one. I don't know how they could do it, because I could stand back and look at it and tell that it wasn't squared up. Now when I frame, I don't measure the diagonals to make sure that they're the same length. What I do is I put a plumb on this and make sure it's plumb, okay? And then I put it over here on this one and make sure it's plumb before I nail them in. So I make sure that those two are parallel to one another, right? And then all these four sides are the same length. So when I do it, I build an opening, and I've never seen anybody measure the diagonals of a door when they were putting it in. I make sure that these two are parallel. I make sure they're plumb, right? So I put my level on each one before I nail them in, and I make sure that they're plumb, not level. They're not level. They're not level. Level, right? They're plumb. Got it? Understand the difference? Okay. So they're plumb, and then I make sure this is 36 and 36 and 82 and 82. And then if these two sides are the same length and they're parallel, is this a parallelogram? Yeah, it is. But how do I know it's a rectangle? So again, here's that thing. I've got this, well, same length. I know it's a parallelogram. But again, how do I know? How do I know it's a rectangle? I don't measure the diagonals. I don't measure the diagonals. I don't measure the diagonals. I make sure that these two are parallel and that they're congruent, so I know it's a parallelogram. But how do I know that it's not kind of in there scawampusy? How do I know it's a rectangle? Someone said something about right angles. Do I have some right angles here, do you think? Do you think this might be a right angle?
You just make sure that the top and bottom.
When I'm putting that wall in, I don't measure it. But when I poured the cement floor in the basement, guess what I made sure about with the cement floor? It's level, right? It's level. So when I look at my little thing here, and I look at where my bubble is, it is right dead center when I put it on that floor. Okay, so this is level. These are plumb, right? Is that a right angle? Okay, now we have a right angle, don't we? Okay, so I'm not gonna actually measure the diagonals there. And you actually don't have to be crazy close, because like I said, when you build this, you make this 36-inch opening by 82, and then you put a door in it that's 34 by 81. So you have an inch here, and you have an inch here, and you have an inch here, okay, to have some play with it, right? And the actual door is, the door is 34, but the frame around the door is about a ½ inch. So you actually end up with a total of an inch. So a ½ inch all the way around, and at least a ½ inch here. And then you can put shims in it and square it up. And have you ever opened a door and as soon if you just unlock it, it just opens itself? It won't stay closed. Have you ever seen a door like that? Why does it do that? Yeah, it's not plumb. It's not plumb in the opening, and so it's leaning one way or the other. The door wants to open. Have you ever had one that if you leave the door open, it'll just close on its own? That's just the opposite problem. It's just leaning the other direction. Okay. Okay. Let's turn to page 392 for a minute, and on example 6, just down on the left below that, there is a figure in a coordinate plane. You all see it? Okay. So, is it a quadrilateral?
Yes.
All right, it's 4-sided polygon. Can we go further than that? Look at AD and BC. Are they parallel?
Yes.
Are they the same length?
Yes.
Yeah, I mean, when you're looking at the slopes, if from D to A is up 4/1 and C to B is up 4/1, not only are the slopes the same, but the Pythagorean theorem is going to say 4 squared plus 1 squared equals 4 squared plus 1 squared, isn't it? And do you even actually have to figure out what that is?
No.
Square root of, yeah, they're both the square root of 17. Who cares? We just want to know that they're the same length, right? Okay? So they're both, so those two are parallel and the same length. Is that a parallelogram?
Yeah.
Okay. Now, can we go further? Is it a rhombus?
Yeah.
Is it? So from A to B is up 1/4, and from D to C is up 1/4. So I guess we can safely say that 4 squared plus 1 squared equals 1 squared plus 4 squared. Is that agreed?
Yeah.
Yeah, they're the same length, aren't they? So I like it better when they're in a coordinate plane because I can have more tools, right? You guys look like you want to pack. Is it that time? It's not that time yet, is it? Here we go.